Okay, find the perimeter of the hexagon ABCDEF if the side of the external regular hexagon is 6 centimeters. Now, those of you who know me know I don't like geometry, right? But still, there is a way of doing these questions. Now, we know in a hexagon, this angle is going to be 120, correct? We are aware of that, right? Now, when that is 120, as you can see by the figure and by symmetry, you know this is 120. Correct? It is visible by symmetry. Correct? As simple as that. Also, when we look at this, or I can put it in a different way, you know this is 60. This is equilateral triangle. Correct? This part is 60. Just this part. So the other two combined will be 60. So it's 30, 30. So this is 30. This is 30. Now the whole point is, what do we need? We need A, B, C, D, E, F. So I need to find the value of AB first. Okay, AB is like AF or something, and then I need to find the value of BC. That is predominantly what we are looking at. Is that clear? Cool. Now if you look at this triangle, you can say this is 60, this is 60. So you can say AF is basically equal to AP. In short, AF is equal to AP, and AF is equal to AB, which is equal to CD, which is equal to DE. So for these four sides, all I need to find is, I need to find the value of AP. As simple as that. Sine rule is what I will go by. Yeah, AP. So I know sine 30 by AP is equal to sine 120 by PQ. PQ is 6. Sine 120 sine 180 minus 30, which is sine 60 by 6. Sine 30 is half, sine 60 is root 3 by 2. So I can say 1 by 2 AP root 3 by 12. Root 3 by 2 into 6. So AP is 6 by root 3. Right? AP. So I have 6 by root 3, which is 6 root 3 by 3. Correct? 6 root, which is 2 root 3. So if I'm looking at these sides, 1, 2, 3, 4, 4 of them will give me 8 root 3. So the answer is greater than 8 root 3 for sure. Okay. And look at these two other sides. When I'm looking at them, I can see very clearly that they are shorter sides. Shorter. If each side was 2 root 3, this is surely less than 2 root 3. Each side, BC and FE, each side is less than 2 root 3. Imagine if they had been 2 root 3, then 2 root 3 into 2, 4 root 3. So answer would have been 12 root 3. But the answer, when you're looking at it from that perspective, you know very, very clearly that the answer cannot be more than 12 root 3, right? So if I know the answer cannot be more than 12 root 3, this and this is gone, only this is left. That means even though it looks shorter, the value will probably be the same. Clear? Clear? Also, whenever something like this pops up, you generally know that at the end of the day, there is a very, very high chance that it's also going to be a regular hexagon inside. There is a very high chance of that. Okay. Now, if I wanted to go ahead and prove, how would I have done that? How would I have done that here? Once again, I would have said the same thing. If you look at this triangle, okay, I can turn around and state PF is equal to UF. PF is UF, and I know PF is equal to AP. So UF, I know the value of UF is going to be equal to AP, which is 2 root 3. And if you look at UFE, this is 60, 60, 60 equilateral. So FE is equal to UF is equal to AP, which is 2 root 3. So each side is 2 root 3. So 2 root 3 into 6, 12 root 3. So even though while looking at it looks smaller, it still helped me because there was no option which is smaller. So I knew it had to be equal and I did it. So even if you did not know it will be a regular hexagon, now you know it will be. So the answer is 12 root 3.